We have amongst us now Professor Pushpak Bhattacharyya as our next speaker in the panel. Professor Bhattacharya is the Professor of Computer Science and Engineering Department at IIT Bombay, and he is also the ex-director of IIT Patna. May I invite Professor Bhattacharya for his talk. The title of his talk is Automatic Essay Grading.
Thanks to Professor Kothari, Anjali, and Ashoka University for giving me this opportunity to talk in this workshop. And one of the themes of this workshop was AI in education. So I took this particular topic for discussion, automatic essay grading. I have a PhD student, Sandeep Matthias, who is about to graduate, and his PhD work is on this particular topic. For last 3-4 years, we have been investigating this area. And there are other students of our lab who have contributed to this work. Now, as Professor Chandrasekhar said, AI has indeed permeated all walks of life. And Professor Kothari also said that machine learning and data, this particular combination is being used in many tasks of life, many human activities. Now, essay grading is a difficult problem, as we'll see as we go through the presentation. And it's a very important task, a very frequent activity for teachers in schools, for example. And also applicants are typically asked to write essays on different topics. Now, when we looked at automatic essay grading, we understood that this is a task involving both machine learning and natural language processing. Now, why is essay grading a machine learning task? To understand that, a very brief perspective on machine learning is in order. Now, machine learning algorithms fall in a spectrum, going from the simplest situation of table lookup up to deep neural networks. And as we go from this end of the spectrum to deep neural networks, the inscrutability increases. So in tables, everything is out in the open. We can explain all the patterns. In deep neural networks, the explainability is very low. And in between, we have systems which are based on rules and statistical machine learning, like support vector machine, logistic regression, etc. So if I take an example of the task of deciphering, if a pattern is the English alphabet A, then we do see that the instances come in many shapes and sizes. So variability is a property of this task. And this variability diversity is a key point for most of the AI tasks, including automatic essay grading. Now, the first A is the classic A, and the last A is only a suggestion of A. Now, we may store all these patterns in a table and apply some kind of edit distance or Levenstein distance, etc., to decide if a new pattern is A or not. Now, the question is, how many such A's shall we store in the table? A can come in so many different shapes and sizes. So it is better to look at the essential properties of being A for a pattern. So can we really hit on the essential A-ness? What is the meaning of a pattern being an A, the essential A-ness? So that gives rise to rule-based systems, and a human being who understands the A-ness will write a rule of the following form. Letter A is formed from two inclined straight lines meeting at a point with a horizontal straight line cutting across. So the essential features are two inclined straight lines meeting at a point and horizontal straight line cutting across. Now there are exceptions to this rule. The two lines need not be straight ones. They need not meet. The third line need not be horizontal, and it need not be straight also. So this leads to false negative or error of omission. There would be valid A patterns which will be classed as not A, leading to error of omission. And when we relax the conditions to accommodate more patterns, we may commit error of commission, which is false positive. Now, the insight obtained from working on many and diverse sets of AI problems is that it is very, very hard to eliminate completely false positives and false negatives. AI problems have these very important characteristics that their boundaries are gray. Okay, does an instance belong to this particular class or not? Many times, this question is not a black and white question. And even human beings cannot achieve 100% elimination of false positive and false negative. So decision making under uncertainty becomes very important, as Gautam emphasized in his presentation with a beautiful example of extracting information from invoices. So we have to make decision under uncertainty with error bound. And how do we measure how far is the decision from exact decision? So we need a scoring mechanism, and that is where probability comes into picture. So data plus classifier is the modus operandi, is the paradigm, along with probabilistic scoring. And this paradigm often performs better than human decision making. So with lots of data, we can learn with high precision, high recall, thereby reducing considerably the error of omission and error of commission, the so-called false positive and false negative. But we often depend on human engineered features. This is in the era of classical machine learning. And these human engineered features have to capture the essential properties. Now, even that is reduced considerably. Human biases are reduced considerably when we resort to ideal deep learning system, where we build end-to-end systems from raw input to classification decision. So this is the perspective on machine learning, which will have bearing on the automatic essay grading problem too. Now, automatic essay grading is also a problem in natural language processing, and the enormous importance of natural language processing cannot be overemphasized. So here is an example of a call center which is supposed to deal with customer complaints, but the number of complaints is so huge that there is this problem of scale, and automation is needed. Now, this automation requires natural language understanding, automatic speech recognition, and most importantly, sentiment and emotion detection. A picture which has come to stay for natural language processing is this NLP stack. We go from processing of words up to discourse and co-reference processing, including pragmatics. We pass through part-of-speech tagging, which is shallow parsing, and deep parsing and semantic role labeling. The other important point is that natural language processing is a three-dimensional problem, at least a three-dimensional problem, where we have problem axis, the language axis, and the algorithm axis. We have to build algorithms for solving important and interesting problems for different languages. Partha, towards the end of his talk, mentioned multilingual learning in a country like India, which is so relevant and so important for the country. Now, in natural language processing, what is the crux of the problem? So again, many years of work on natural language processing had revealed one important point, that the exact challenge of natural language processing is in ambiguity resolution. Starting from speech and going up to discourse pragmatics, at every stage of processing, we encounter ambiguity. So if I take this sentence, I got a plate, and utter it very quickly, it is not clear what did I say. I got a plate or I got a plate. Lexical ambiguity is at the level of words. So if you look at this sentence, which appeared in one of the newspapers recently, Maharashtra reports increased cases of COVID-19. So depending on whether the word reports is noun or verb, the meaning changes completely. And if I take these three words, this is an example of word grouping or parsing ambiguity. These three words, no dogs please, can give rise to four meanings. Dogs are not allowed, no, dogs are allowed, there is no dog that gives pleasure, and no, dogs do give pleasure. And on top of that, if I take different senses of the word dogs, then the scale of the problem becomes multifold. So this is the ambiguity of grouping. Semantic role ambiguity is also very well known. This is a classic sentence: flying planes can be dangerous. So what is dangerous? The act of flying or the planes themselves. Then pragmatics, sarcasm is an example of pragmatic ambiguity. This is a tweet for a particular airlines. Thank you for sending my baggage to New York and myself to Chicago at the same time. Brilliant service. This is a sarcastic sentence with surface meaning being different from deeper meaning. Discourse and co-reference ambiguity. Anaphora is a classic problem again. The cat went near the dog and it bit it. Who bit whom is not clear. Then we have additional ambiguity coming from multilinguality and code mixing. So this sentence, इस हर्ष स्थिति में भी हर्ष का हिम्मत देखकर मुझे बहुत हर्ष हुआ. So इस हर्ष स्थिति में, this harsh is English, स्थिति में, and is indicative of language switch. इस हर्ष स्थिति में भी हर्ष, this named entity, का हिम्मत देखकर मुझे बहुत हर्ष हुआ. This is proper, this harsh is proper Hindi word. So this is an example of code mixing and multilinguality, bringing in additional change for natural language processing, additional challenge for natural language processing. Now, deep learning and natural language processing are sort of made for each other in the sense that natural language processing happens in layers and one needs back and forth flow of information for solving many kinds of ambiguity. So if you look at this sentence, I saw the boy with a telescope, which is a classic sentence, who has the telescope? But I saw the boy with the telescope, which he dropped accidentally. The ambiguity is removed here. But to remove that ambiguity, you have to do anaphora resolution, clause construction, clause detection. And therefore, there is a chicken and egg problem. There is a cyclicity in the problem, which can only be broken by back and forth information transfer between different NLP layers, which deep learning is capable of doing. We are doing natural language processing research at two places, at IIT Bombay and IIT Patna, which is a new lab. And IIT Bombay lab is since 2000, and we address many different areas of natural language processing, starting from machine translation going up to cognitive natural language processing, where the eye tracking signals are used for NLP decision making. And we believe that linguistics is the eye and computation is the body. The insight from linguistics is very, very important. Partho talked about use of knowledge graph in deep learning, and knowledge graph often has to make use of deep linguistic knowledge as well as word knowledge. Now coming to the proper topic of the talk, our investigation into can essays be scored automatically. There has been a steady stream of publication in this on this topic from my students, and started from 2018. Now, an essay is a piece of text written in response to a topic. This is called a prompt. All of us have written essays on cow in our school days. So cow, the topic of cow is the prompt, and the piece of text is the essay. Now, can these essays be automatically scored? This is the AEG problem, automatic essay grading problem. And essays have traits, for example, content, organization, style, and so on. So can we aggregate decisions on these different traits and combine them to produce a decision on the quality of the essay? So that is the problem statement. Now, why is automatic essay grading a machine learning problem? Because there is very large variation in the way the essays are written, even for a single topic. And it is very difficult to capture all situations using rules. For example, one of the prompts, which I'll show later, is decide if the essay genre is laughter. Now, suppose I sit down and give this rule, has a situation involving slipping on banana peel. If a person slips on banana peel, that typically gives rise to laughter or mirth. And the rule, therefore, is this. The essay has a situation involving slipping on banana peel, and therefore it is the decision is yes, it belongs to the genre of laughter. Otherwise, the answer is no. Now, this is the picture of a person about to step on a banana peel, and he or she might slip. Now, the rule says slipping on banana peel is humorous. but this has a false positive situation. If a lame man slips on a banana peel, then it is not a very humorous situation. This person has a disability. So this way there are false positive and false negative situations abounding in essay grading also. So that makes it a machine learning problem. So automatic essay grading needs data plus machine learning. Rules or regularities, underlying regularities do exist, but such regularities are not apparent, not expressible, not robust. That is, has a lot of false positive and false negatives. Therefore, we have to resort to data, and we have to rely on data to extract these kind of regularities for decision making. Now, age is also an NLP problem. That means NLP stack does come into play when we deal with the automatic essay grading problem. For example, if you have an argumentative essay, then we need to know the writer's sentiment for this essay. So this is a sentiment analysis problem, which is an NLP task. Source-dependent essay are concerned with answering the prompt correctly. That is, given an essay, is the response to the essay correct? So this involves question answering and text entailment. Again, two important NLP problems. Are the characters properly portrayed in the essay? This is entity recognition and co-reference resolution. Again, NLP problems. So automatic essay grading is very eminently a problem involving both machine learning and natural language processing. So the problem statement is the following: input is an essay and output is a score. Now the essay traits are pretty well known, but these are documented in many research papers well. The content, which should have good quantity and relevant to the topic or prompt. The organization should be well structured. There should be introduction, body, conclusion, etc. The style should be engaging, should not be belabored, should be simple. The word choice should be appropriate, should not be bombastic, simple words maybe. Sentence fluency, the decision is whether sentences are short and fluent versus convoluted. Does the essay adhere to the prompt? It sticks to the topic, relevant to the topic. Coherent sentences and paras should hold together. Argument strength should be convincing. Writing conventions should be followed. Spelling, punctuation should be appropriately adhered to. The development should be easy so that the reading is smooth. Develops the character, setting, plot, etc. very smoothly. Thesis clarity, the main idea should be well expressed, and narrativity well organized and well developed. So all these are well-known traits of the essay. When we talk to teachers who teach English, who teach language and grades essays, they agree with these kind of traits. Now we looked at the area and found that for last 12-15 years, there has been continuous work on a detection of various essay traits and scoring those traits. And in this chain of work, I think our work came into existence since about 2017-18, where we published on scoring based on style, multiple traits, and holistic scoring. But we do see lots of papers on coherence, argument strength, stance, organization, etc., etc. Now, for our work, the data set that we chose is a pretty well-known and benchmark data. This is called ASAP, Automatic Student Assessment Prize dataset. It contains 130,000 essays written in response to 8 different prompts. And the types of essays are narrative descriptive, argumentative persuasive, and source dependent. So write an essay about your summer holiday is a narrative essay. Will defunding the police department reduce police brutality? It is an argumentative essay. And source dependent essays, there are many examples. So here, for example, this prompt number 3 to 6 are all source dependent essays. Prompt number 8 is interesting. Write a story in which laughter plays a part. And this is the prompt for which I described this example of slipping on a banana peel. Now, the trait information, this prompt 1 to prompt 8, they emphasize different traits. For example, prompt 8, which is on laughter, it emphasizes content organization, voice, word choice, sentence fluency, and conventions. Now, the statistics is the following for the data. We found that in prompt 8, the sizes of essays were larger than others, about 600 words on an average. But the source-dependent response type essays had much shorter length, about 100 to 150 words on an average. The models that we tried are both classical machine learning and deep learning models. So the first model was based on random forest with feature engineering. The next model was histogram intersection string kernel. Then the last two models are based on deep learning. The first one is hierarchical convolutional neural network LSTM system. And the most recent work is based on multitask learning, where all the traits are decided on and these are aggregated to give an overall score on the essay. And usual 5-fold cross validation. The evaluation metric is quadratic weighted kappa. So why quadratic weighted kappa? Because kappa score is essentially a measure of agreement and disagreement. And if we do random chance assignment, for example, if we assign all the essays the mean grade, then the kappa score is 0, but we get non-zero accuracy and F-score values, which is misleading. Then accuracy and F-score also do not penalize properly the distance of the mismatch. For example, a score of 1 mismatches both 2 and 3 score, but the distance from 3 is larger. So weighted kappa will penalize a 3 mismatch much better than 2 mismatch. And also we found that quadratic kappa is better than linear kappa in the sense that the penalty assignment is much more realistic in this case. Now for random forest, the features were based on length, punctuation, syntax, entity, language modeling, and readability. Then for histogram intersection string kernel, the main idea was to create a feature vector based on matching. So in the training corpus, if we have n documents, then for every document we create pairwise similarity. This similarity computation is done by the histogram intersection string kernel score. It is normalized also. And for a new document, we get a feature vector, which is essentially a sequence of similarity scores with existing training documents. And we pass it through a support vector regressor to get a score for the new document. So it is essentially based on similarity. Now, from 2019 or so, we moved to deep neural network based methods because the data size was reasonably all right, about 130,000 documents annotated by traits. Now here, of course, the model is very standard, usual model. So there is this word embedding layer and word level CNN layer, which extracts the n-grams. Then these n-grams, the internal agreement between these n-grams are exploited in the attention pooling layer, from which we get the sentence level encoding. And sentence level encoding passes through the dense layer to give a score to the essay. And this is done for each and every trait. So this is a trait dependent model. These models are giving scores based on each and every trait. So for every trait, like organization style, etc., we have a different CNN LSTM model. So when we investigated the results, we found that for all these traits like content, organization, word choice, fluency, etc., everywhere the deep learning system, which is a combination of convolutional neural network and LSTM, could outscore the systems based on random forest and the string kernel based methods. So classical machine learning, deep learning methods were better than classical machine learning algorithms. We also investigated the problem of scoring the essay holistically, that is a multitask learning. The primary task is overall score of the essay and auxiliary tasks are trait scores. So can we combine the trait scores to arrive at an overall score for the essay? So the approach was obvious. The trait scoring models were all taken and then combined into a single network where parameter sharing happened, and this was the case of multitask learning. Not only were the scoring mechanism for different traits learned, they were also combined at a layer close to the output layer to produce the overall score of the system. So when we analyzed the results and compared them, we found that this multitask learning was giving a good score in almost all the prompts, in majority of the prompts. And its mean quadratic weighted kappa score was also better than, was very acceptable. Any score which is more than 0.7 is reasonably good for automatic essay scoring. So multitask learning with by LSTM gave us a good system for, at least for this benchmark data. We also compared this system with kernel and single task learning systems, and even though the results are mixed, we found that the multitask learning system did approach a reasonably high score for the problem. And multitask learning, where all the single task learning models were combined together and the overall score was found by aggregating, this particular system was much faster than the single task learning systems combined together. So based on these observations, I had to cut down on many material and many details on this particular problem for lack of time. So based on our investigation, we arrived at the following conclusions. Deep learning is better at generalizing across different traits compared to feature engineering based systems and a string kernel based system. So this has been consistently observed. And multitask learning is effective for holistic scoring, though at many places it was not able to do better than single task learning, but the indications are that if we train the system sufficiently and apply different kinds of strategies like additional knowledge, background knowledge, and so on, we'll probably do much better. But one of the important plus points of MTL is this low training time for the data. Now, one problem we always faced is this: the data for these 8 prompts were given, but suppose we had to deploy our system for general essay grading scenario. So the domain would change and then the system performance would fall. We have used this system in some central school settings and asked the teachers to give feedback. So we understood that cross-domain automatic essay grading is a very, very important problem. Okay, and we have to investigate this particular area very well. Similarly, multilingual. So whatever I said is linked from my homepage in the form of publications. And finally, a message which I actually repeat in all my presentations. NLP is really a task in trade-off. When you have too much of information, then there can be topic drift and ambiguity is inserted inadvertently. And if the information is too little, if the clues and signals are too little, then it can lead to data sparsity. So we have to adopt a middle ground, which Lord Buddha had preached some 2000 years back. Thank you very much for your attention.
Thank you, Professor Bhattacharya. This was indeed a very analytical and quite technical session, very, very interesting, because students from AI definitely look forward to essay grading, and this is somewhat which is very, very interesting. Now we can take some questions from the audience.
Sure.
So we have questions regarding writing an essay using AI. So there is one question which talks about if the input is an essay and output is a score, we are somewhat trying to build a universal grading rubric. Don't you think that a human grader bias is an important input?
Okay, so when we created annotated data,
right?
The question is, when you create annotated data, can the human bias influence the machine learning performance? Yeah, yes, that is true. We know that there are different kinds of graders. Some are extremely strict graders, some are lenient. And the way they annotated the data would definitely influence the machine learning algorithm. And this is an inevitable fact. We really cannot shy away from the situation. Data does influence the machine learning model. So the trick or the way out would be to, the answer is obvious, get a lot of data from many different kinds of annotators and train them.
Yes. Okay. Another thing that there are questions regarding coherence of answers metrics. So there's one person who has asked, Venkatesh has asked, how does one handle scenarios where factual consistency is a key in grading?
Can you repeat this, please? Sorry.
So there's a question regarding coherence of answers metrics like rogue or coherence are agreed to be flawed and do not represent factual inconsistencies in the text. How does one handle scenarios where factual consistency is a key in grading?
Oh, okay. So this will fall in the source-dependent class, source-dependent type of essays, where the response essay should be consistent with the source essay,
Right.
for which this current essay is a response. So how do you detect the consistency? So consistency detection problem is a well-known problem in natural language processing. Gautam referred to logic. And text entailment is the area, the text inference or text entailment problem is the area which detects consistency. And a lot of deep learning based systems have been created for text entailment also, where there is no explicit use of logic. So I would say that text entailment combined with data-driven machine learning system is the answer.
Right. Okay. That's pretty comprehensive. There's another question. Okay, so there are two more questions that we can take before we end this very interesting session. One is on online exams. So a person has asked, can this be applied to online exams conducted for grading?
Oh, of course, yes. That is the final aim.
Absolutely.
Yes,
Yeah.
yes.
It's actually online. So does this application take care of quality? There's some questions related to quality, whether quality is also an important aspect when we talk about AI applications. So can this help in addressing the quality concerns?
Okay, if I understand correctly, quality of the essay grading system or quality of the essay. So
The essay with few words compared to larger number of words.
oh, okay. So if an essay is extremely brief, okay.
Right.
So I am motivated by what Blue did. So Blue is a metric which is an evaluation system for machine translation. So there is something called brevity penalty. Okay.
Right.
So in the Blue scoring system, if the machine translation output is extremely small in size, very few words, then there is a penalty associated in the Blue scoring mechanism. So if the essay is very small in size, there can be a penalty associated. But again, we are entering difficult NLP area where brevity need not be a disqualification, because the words are so well chosen, the organization is so compact, so well neat, that the essay really makes the point properly. So again, there is no simple answer to this question. Really.
Yeah, so it's a quite generic. Okay, so with this, we come to an end with this of the session, and thank you, Dr. Bhattacharya, for this very, very interesting session.